So is my screen visible? I'm audible, right? Yeah. Okay. So is my screen visible? Yep, got that sorted. Today we're going to be looking at bash scripting. So just like Python or JavaScript, bash is a scripting language. You can use it to write any. You can use it to make anything, like automate anything. Plus, the advantage of using bash instead of Python or JavaScript is that it links directly to the OS. So you can use any command, like I say nmap, it's going to run nmap for me. I don't have to use any other separate APIs or anything for it. So it's just that simple that you can use bash and you can interact with the operating system directly, and it's a scripting language, so you can use that to automate stuff. Now, any language has four parts for it to be a Turing complete language. That is, for it to be able to solve anything that is solvable. So it has to be able to do mathematical functions. So firstly, it has to be able to do mathematical functions, divide and multiply and all that. Then it has to be able to use conditional statements, so if or else, and it has to be able to do perform loops. So with these three, you can technically make a whole proper Turing complete language. Plus, Bash also offers us support for functions or tests. Test scripts are another thing unique to Bash. So we'll be first looking at the basics. So how do we get started with a Bash script? In some Python codes, you might have seen someone write this shebang slash bin slash bash. So this is basically telling us, telling the OS, that telling the kernel that you have to use this bash interpreter. This is specifying the interpreter. So if you were to start with Python, then the interpreter will go and use the Python interpreter over there instead of bash. So we use the bash interpreter, and this is basically the first line. Shebang slash bin slash bash. The next line is you can use anything. So let's start with the simplest part. It's going to be variables. Now variables in Python, they could be anything. Like they have to be alphanumeric, can't start with a number, and they can start with an underscore, but those have separate special values. In Bash, it's kind of different. All variables have to be uppercase. All variables have to be uppercase. They can have numbers, but can't start with numbers. And they also have underscore, but again they can't start with underscore. So let's make a simple program which will use a variable first. So let's say I declare a variable called language, and I assign it the value bash. So this is going to assign the value bash to the variable language lang. And note how there is no space between the lang equal to and bash. That is because when you're assigning a value to a variable, there can't be any space. So also, yeah, comments start with a hashtag. That's how it goes. Then you can use echo to actually display it. So echo dollar language. This is our basic program. We write it to exp.sh. Sh is going to be your extension for anything for a bash script. So now I have exp.sh, but you see that the permissions are not set. You can't execute it. So first we set our permissions. And then we execute it. See, it's going to give us the value held in the variable lang. Also, what we can do is we can just bash treats anything as a string first. So if we do this, it is still going to say that $lang is a variable. So again, we execute the same thing. It's going to give us bash. So it doesn't really matter if the variable is inside quotes or not. It's going to be treated the same. Then the next part is format specifiers. So just like in Python, bash has format specifiers, and that's easier to explain. So I'll say echo, and within quotes let me just give dollar, and then inside the format specifier I'll give my variable, and then afterwards I'll write, let's say, shell. So this is a format specifier. Now if we were to execute it, it's going to give us bash shell. It concatenates it. It basically substitutes. Okay, wait, I'll just open another terminal. It's going to be easier. Okay, so this is our code, and here's what we're executing. So at first we used lang, and that gave us the answer straight out, bash. Then we used a format specifier. It basically took this, it substituted bash in there, and then it gave us shell. But why use it in the first place? Say we were to say will this work? Yeah, it still works, but it's just easier for us to understand. And see, it didn't give us anything because it realized this is not a variable. It prints out bash first there, then it prints out bash format specified shell. Okay, cool, that works. But it tries to see if there's a variable called lang shell, and there is no variable, we only have lang. So that's why it doesn't print anything, there's no value over there. That's why we need format specifiers. Also we can the next part is what if we can concatenate strings. So instead of going straight up lang shell, what if we went lang space shell? So let's try that. And this will give us bash space shell, because space is going to tell the interpreter that yeah, this is a one variable and this is just a string you need to concatenate at the end. so that also works. And you can also concatenate using the plus symbol. So this is how variables work. What if we wanted to take an input from the user though? What if we didn't want to hard code the values every time? So we can do that in Bash. So first let's have a variable, input variable, that's going to be our variable. And what we're going to do is we can just say read, and that goes like this: read, and minus p is for prompt. So what prompt has to be supplied? So let's say enter a variable. This will prompt the user to enter a variable, and then we take the value of the variable inside the, we take the value entered by the user inside the variable, input 1 maybe, we write it, and now let's try to execute it. Wait. Yeah. So it asks us to enter a variable. Now what if we enter, let's say, hack. Yeah, we didn't actually do anything with it, so it just quits. But yeah, it asks us for input. Let's just say echo. Okay, now it will just print out our variable back to us. Let's try that. It printed it out back to us. What if we wanted to, so this is an example of a single line variable here. What if we wanted to read in multiple variables at the same time? So let me just comment this out first. And let's read in another one. So read minus p, that's the prompt. And then we take input 1 and input 2. Then we can just print those out. So this should print out both our inputs, and let's just write it to the file. Okay, now let's run it. So enter two variables. So the first variable, let's say I enter, and the second variable is going to be, so first input cat, second input dog. It basically separates them by space. So like, any doubt till now?
No.
Okay, cool. So let's move on to the next part. The next part is going to be if and else. So I'll just close this file and I'll make a new one. So if and else is pretty intuitive in Bash, and if statements start with if, then there is a condition. Sorry, there's a condition here. and then there is a semicolon, and then this. Then indentation is not required. It's just for it's just so we can read it properly. Then there are all the commands that you want to execute. And finally, when the if block terminates, it terminates with a free. So like if, then free. Now let's just first get the interpreter right. And then let's make our if condition. First we have our variable. Variable is, let's say, root is apple. And then in our condition, let's we can say like in this case, you have to note that there has to be a space between the equal to and the values, because equal to with spaces means it's a logical operator, equal to without spaces means it is a assignment operator. So and then let's just say this is an apple. So if the fruit is apple, it should execute it. First, let's give it permissions. Oops, sorry. Where is the error? We have fruit equals apple, then if fruit is apple, honestly that's just how it is. If fruit equals apple, then oh yeah, there has to be a space between all of these. So that's how the interpreter sees it. There has to be a space between the opening and closing of the brackets, and between the equal to and the variables and whatever values you're comparing. So it is an apple, it's going to give you this is an apple. So what if we say the variable fruit was an orange? It's not going to give me anything because the if statement doesn't it isn't true. We can also have an else in here. So if then or else echo maybe the name of the fruit. So let's see if it runs. See, it gave us this is an orange, not this is an apple, because the name of the fruit was orange. This condition didn't satisfy, so it skipped the then part and it went straight to else. And that is how basically that's how the if statement works. But this is just comparing a value to another value. What if we want, let's say, what if we want it to give us less than or greater than, those kind of logical operators. So I'll just give the value of fruit is 1, and then if fruit is minus LT means it is less than. So if fruit is minus LT2, we just say this is an apple, and else we just say it is an whatever fruit. So we can run this, and it says this is an apple because fruit is 1 and 1 is less than 2. What if we give minus LT 0? So minus LT 0 is going to give us, this is, and I mean this is not logically correct because 1 is not a fruit anyway. The value of fruit is 1. 1 is not less than 0, so it says it skips the then part and it goes straight to the else part, and else part it says this is an and whatever is the value in the variable fruit, so fruit is 1. That's how if else statement works. In case you can also use greater than, so minus gt says it's greater than, so 1 is greater than 0, so it should give us this is an apple this time. Yes, so it gives us this is an apple. And that's again about the if else statements. You can also, you can also nest them inside one another. So if, then, if, again. And you'll have to close it there. So it says fruit 1 is greater than 0, so it prints this is an apple. Then I asked if 1 is equal to 1, and yes, it is equal, so it goes to the then block and it prints out nested if, and it closes this if statement right here before it comes out and closes the outer if statement here. Basically, that's how you can nest if and else statements. That's all for if and else. So you guys have any doubts in if and else?
No doubt.
Okay, cool. Then we can move on to loops. So you already have your basic for and while loops in Bash. You also have a until loop. So for loop, let's just look at for loop first. Okay, the interpreter is been declared. Now for is how we started, for variable in, and we have to give a list over here. So a list is going to be in parentheses. I say this. So this is our list. So it's going to iterate, the variable is going to iterate over every word in this list. Then we say do, and we can give it a command. So let's just say echo dollar variable. This is just going to print out our variable, and then after if we want to come out of the block, we want to say that the for block ends here, we just say done. So for anything inside the for loop starts from do and ends with done. That's how the interpreter knows what statements to execute uh, in the loop. Now we can just oops. Gave us the error this time. We don't even have to specify the parentheses here. So we can just say instead of, okay, we don't need commas. Interesting. Why is it not printing variable? Why is there an error over there? Yeah, okay, so that's how it was. You don't need a parenthesis if you're not giving it a command. So right now I'm not giving it a command, I'm just giving it a list. So it's going to iterate over the list. First variable is going to take the value of this, then it's going to take the value of is, then for and loop. So that's why it's printed in a new line every time. What if so this is going to do it over a list. Now what if I wanted it done, let's say this doesn't have a lot of practical use, right? I mean, you're already giving it a string and everything. So what I can do is I can have it iterate over, let's say, a command. So right now if I run ls on my current directory, I have 3 files. So what if I say for file in, and this is where the parentheses comes in. Ls is going to give us all the files in the directory. Do cat dollar file and done. So see, it's just giving us all the files printed out, and this is where the first file begins, user input and variables. Then this is where the second file begins. This is the if statements, and this is the current file, bash. And in that way I can even say like cat file and then grep for, let's say, bash. It should give it 3 times. Yep. See, we got here, and then we got this and this. Also, we got it from the cat command here. That's here. And not just ls, we can basically any command you can run on the terminal, you can run inside a bash script. So here it can be like any command. Like I can let's maybe ls minus al, and then I'll just say echo file. Oops. Yeah. So I run this, and it's just going to give me the whole ls minus l thing, but it's since it's giving it in a, it's going to iterate over it, right? So this is going to return a list, and a list is going to be separated by spaces. So every word separated by space is basically a new word, and it's going to be printed in a new line. So if I actually run the ls minus l command, this is what I get, right? So total space 12, and then next line what the permissions, then space, then the user, the owner, and then the user. So that's what it's doing. See, total space 24 space the permissions, then the whole thing. It's just giving every word in a new line. So this is for loops. You can also say another loop. It's called okay, fine. Let's just look at while loops first. Then we'll go on to the until loop. So while loop starts with while, and then let's say we have a variable a is equal to 0, while variable a is less than 10 to yeah, and then done. Okay, fine. Let's just print it out then. Oops, again I forgot the spaces. I'm so sorry. Oops. Okay, it's not going to do 0 plus equals 1. Come on, I know loops. How do I not know plus plus? So while a is less than 10, we have okay, so we do this. We have the variable a, and we assign it to whatever's in the value of variable a. So that's $a plus 1. That's how we assign a value to a variable. Okay, so this should implement it. Line 14. What is line 14? This is an integer expression. Yeah, so here we got it. There was a mistake in typecasting. So what happens, like I said, is that A uses, Bash basically treats everything as a string first. So that's why any input you take, it's treated as a string, and then you can typecast it to an integer or a float or whatever. So that's what's happening. You couldn't add a zero to a zero was taken. A one was taken as an integer, but then the zero in a, that was treated as a string. So you couldn't add a string to an integer. So what we did here is we first added it, and then we finally typecasted the whole thing. And because of that, yeah, it worked. So it gives us 1 to 10 all the values, and this is how a while loop works. You can also say while a is not equal to 10, do this, it will give the same result. Okay, and then the next one is going to be an until loop. So till now, as we've learned, a loop basically executes till the value inside the condition is true, right? So uh, an until loop is like the opposite. So it basically does the opposite. It executes while the value inside condition is false. Now, oops. So let's write a until loop. And then you're going to have a condition over there, a condition which has to be false. So let's say okay, let's just do the number example again. So until, let's have a variable first, a equals 0 until let's put it in a square bracket. Okay, until not is less than 10, say. Okay, again the same example. It's going to do and then done. Do, let's say again, print it. So oops, I didn't add it. A equals typecast a plus 1. Yeah, so it does the same thing again basically. These are the three kinds of loops you have in any, in Bash. So unlike in C you have for, while, and do while, here you have for, while, and until. Like, any doubts while in the loops part? Okay, none. So we'll just move on to the final part for today, that's functions. Functions.sh, and I'll just okay, now that the interpreter is out of the way, let's start with there are two kinds of ways to define a function. So basically you can say function, then name of the function, parentheses, and then you can start, and then let's say echo and then end the curly braces, and you can just call it like That's all. You don't have to specify the parentheses. That's just how you call it. And see, it says in a function. The other way is you don't even have to write a specify function here. You can just start with this. Even then it works. Basically, that's all for a function. You can even pass it arguments, and you can use those arguments inside the function. You can another thing about this is you can call functions within functions. So bin is another function, and I'll say in bin and close it, and I can just call bin within foo. So and it says in a function and then in bin. So that's how you do nested function calls. And finally, we'll look at passing arguments, and then we'll wind up for today. So the function arguments in Bash are again just the same as in Python or whatever programming language. So you're going to pass them. Okay, let's just pass one to foo. So when you're doing that, you can have a again the scope of the functions is the same like in C. So anything here you'll have to specify it's a local function or a global function. So local I mean a local variable or a global variable. So local and this is going to be only accessible inside foo. If you want to pass argument over there, you can now of course use a global variable. So here you can say and now you can say like here let's say you can access varlock here, and you can also access the global variable here. And here however at the end you can only access the global variable. So and let's run it. So here what it's doing is it of course it printed out the function and the nested function call, and then it says it printed out the variable local, that's local, and then it printed out the variable global, which is global. But in this case it couldn't print the variable local because there was no such variable inside the scope of this command. The local variable scope started here and it ended right where the function ended. Basically, yeah, that's how you pass arguments. You don't do anything like in the parentheses. You just have global variables, or you can declare local variables inside the function. So, like any doubts? This is the last topic for today. We can find out if there are no doubts.
So you can't pass a value into the function, right, from outside. Like when you call foo, then you cannot pass anything to that function.
No, I mean you can pass it if it has a global scope. But I mean that's just like using a global variable. But
Okay,
there's nothing like passing it in here.
okay.
that's all for today, guys. We're done for the day.